Okay, back again. And so operating systems. Get that on the screen here for everybody to see. Last time I forgot to do that, and that didn't work too well. Okay. Now, I mentioned the disk operating system, the early version of the operating system that we call Windows today, disk operating system, or DOS. It didn't have the graphical user interface. That was the main difference with it. It had a command line. You type commands. It couldn't do multitasking, and it certainly couldn't do multiple processors. There was only one processor. So that was a big difference with DOS. But it used to be that the operating system had that DOS buried inside of the graphical user interface. The graphical user interface would work with DOS. Even Windows 95 and Windows 98 still had DOS inside of it. It just, you didn't have to load them separate. They loaded together. And there was a thing called the command.com, which we still have today. At least it's hiding in there, or there's something that does this same function. And what it did was it interpreted the commands. When you type a command in, it would execute that command. And it had a couple files that it was used for the operating system, which configured it. The command.com was like the kernel. That was the name of the part of the kernel that you would give commands to. It would also read in files when it started up the operating system. So there were files like names with like msdos.sys. That was a file that was used by the kernel. And there was drivers. They would have names like input.io.sys. Those were files that were actually the programs that ran the operating system. Didn't have that many different parts in those days, just a few. Today, there are hundreds of different little programs that run for the operating system that have to be loaded at different times. Not always at the same time, but at different times. But we still have some functions of this. We still have the command interpreter. And when you communicate with the command interpreter, you might give it a command that either it understands directly or it doesn't understand it, and then it will try to find a program that will do that thing. In other words, when you type the command, what you're really doing is you're either giving a command directly to the kernel, which it will then do for you, or if it doesn't know it, it will look for a program with that name and try to run it. That's basically how it works. So internal commands, things like simple or commands that you'd use every day, like setting the time and date, or finding out what's in a file directory. You type dir. Dir would display a list of what's in the file system. I can run the command prompt in Windows here, and you can see if you want to run the command prompt, you can do that a couple different ways. One, if you click on the start button and you look for the CMD command. It'll be on, a lot of times it's on your menu, or you can type it into the search bar, and you get a little. You get this. This is the command prompt. So if I type dir, this is, see, it knows how to do that. It'll give me a directory listing all the things that are in that particular folder. This is my root folder. Let's see, documents. There's a command called change directory, cd space documents. Let's say documents. If I do that, and then I type dir, it lists what's inside that folder. That's whatever I happen to have on this particular computer here. Well, that's the same as if you went to your file manager in Windows. The file manager looks like this. And if I click on documents, that's the folder that I was looking at in the command prompt here. Let's move that down here, see. So there's the, you see some files there that are listing that are in there, and some folders which we call directories in the DOS terminology. They call them directories, but that's really the folders. And here you see those same folders. There's a folder called Arduino. That's a little computer. Compet 206. Right? There's a folder for this class there. If I open up that folder, you can see what's inside there. Same thing over here. In order to open a folder, what you call a directory in the language of DOS, you use the cd command, cd, and then the name of the folder, 206. And now if I type directory, it lists those same things that you see up here. You see, confirming screen, whatever that is. You see it listed here. So it does the same thing as your graphical user interface, just not as pretty. No icons, no folders, things like that. So that's one of the commands that your kernel of your operating system understands. You can copy files, move files, rename files, a lot of other commands too that it understands. But then there's some commands that you might use that it wouldn't know how to do, and those are called external commands. What they are, what you're doing when you type in an external command is, if the kernel doesn't understand your command, then it looks for a program with that same name. So let's say you type check disk. Check disk is a program that checks the disk for file problems, file data corruption. Or if you type edit, that runs an editor. Or formats a disk. Or print something to a printer. Those are commands that are actually programs that you type in and they run. So those are called external commands. And that's still true today. We type in these commands. What we're really doing is running programs. So isn't it interesting that even the latest model, operating system model, Windows 10, has the same ability because it's still built in there. Now, DOS would, when you start up your computer, the old DOS operating system would boot up. And you can still boot up DOS today. You can, the latest computer models, whatever it happens to be, with the latest processors and so forth, can still run DOS. They're still backward compatible. So you could put DOS on a floppy disk, put it in your computer, and if you have the settings in the BIOS set correctly, it would load up the operating system off a floppy disk because it didn't take much space to hold the old DOS operating system. And there are people who still run DOS for things because it's just a simple little operating system, and sometimes they need something real small, or they just have some old program that runs in DOS. There's still people using programs in DOS. Or you could run it in Windows too, because Windows is backward compatible. Now, a lot of people don't know, but you can load an operating system such as DOS on a flash drive. You don't have to use a floppy disk, and a lot of computers will. Not all PCs, the BIOS knows how to do this, I should say. Some PCs don't. Some models didn't have that in the BIOS, but Most later models nowadays will boot up off a flash drive, and you can put an operating system on there, and it will boot up. So if you wanted to try a new operating system, you could install it on a flash drive. Probably not a floppy drive. You could even try DOS on a floppy disk and still work. On these computers, I know it will work in here because they have floppy drives. Yeah.
Windows has a little hiccup, especially if you're booting Flash or
Yeah.
it's not letting you do it. I mean, I checked the BIOS on it, it's just not recognizing it.
Yeah, they have something in the BIOS that you have to change the settings of to let it do that. You're right. That blocks you from booting up. It's supposed to be a security feature, right, to try to keep people from accidentally loading a virus or something from a rogue operating system. So that's why they do that. But you can do it. You just have to go into the BIOS settings to do that. Well, another thing that we still have today are all of our files. If you look at in your operating system, all our files have names. You see here. If you go to the hard drive here and look at the program files, and there's a folder called program files that contains the programs, the application software. And of course, they all have names. And if you open up, say, one of these, look inside, oh, let's say Java here. That one didn't have much in it, did it? Try that one, okay. And you see a lot of different files in there. Some of the files, not all of them, but a lot of them have a name of some kind, and then they'll have a dot and then DLL. Or some letters, or here's one that says checksum.mds, or here's one that says something UNS, something .dat. Those three-letter extensions help to tell what kind of a file it is to the operating system. And that came from DOS. It was called the DOS naming system. Originally, you could only have up to 8 letters for your names. And then you had a dot or period, and then 3 letters after that to tell what kind of a file it is. Well, the eight letters requirement is no longer imposed on us. We can have more than 8 letters and numbers and characters in the name. You can have a long name now. So that isn't necessarily the case anymore. But we still have the extensions. The extensions are still used today. And so there's lots of different file name extensions. And the purpose of the file name extensions is to identify the kind of file. Here's a list of some common names. There's lots of them, lots of different file name extensions, but bitmap might be for a graphics file, or a .com file would be a command file. That's a little program that would be one of those external commands that the kernel doesn't understand directly, but would be run. If I type in checkdisk.com, it runs that program. It's a program. It's just another name. There's another extension that is also a program, .exe, an executable file. It's a program that will run if you type in the name. The difference between these two kinds is that the exe programs tend to be bigger than the .com. .coms are little programs, tend to be little small programs. There's some limitation on the size of them, where the .exe tends to be larger programs. A doc file would be a document file, like your word processor uses, like Microsoft Office or LibreOffice or something like that. A DLL file, that's a part of a larger program that has several files that are loaded at different times to run that application program. So there are a lot of times some programs are all one file when you load them. It's just one single file, but other programs have several files and they might use something like a DLL file, several DLL files that make up a larger program. And different DLL files get loaded at different times depending on what the program's doing or what kind of features are being used. So it doesn't necessarily load the entire, all the files for a given software application. There can be several. Initialization, INI, that stands for initialize. It initializes, it's some kind of a file that contains information that either some application program runs or some operating system function uses that file to configure something. Or a log file, that's some file that lists actions that have occurred. Something, when something happens in the computer, there's usually some kind of file that it will record something in there, and you can use that sometimes for troubleshooting purposes. Programmers might use that. Or a text file, that would be just a plain text file like a simple word processor might, or text editor might produce. And like I say, there's many others out that you will run into. Like, for example, MP3, a music file, or maybe a JPEG, JPG. That's a picture, another kind of picture. Now, file names they can use all the letters and numbers of the alphabet and a lot of the characters that are on your keyboard, but there are a few characters that are not allowed because they're used by the operating system for special things. So these are some of the characters that you're not supposed to use for your name. Other than that, you can use all the letters and numbers, and spaces and things like that are allowed now. Didn't used to be able to put spaces in there either. Now you can put spaces. Now, when you start up your computer, it has to load the operating system. That's called the boot process. And there's two ways you can have that happen. You can either turn your computer on, which means it's been off, and then it loads it up after you turn it on. Or you can do a warm boot, which is where you restart the computer which has already been running. And there's actually a special key sequence, if you type it Control-Alt-Delete, which you can use to get the attention of the operating system. In earlier versions of Windows, when you typed Control-Alt-Delete, it would reset it right then and there. It's like it's like turning it on and off. Later versions, when you do that, it will put up a message on the screen and give you the option of doing that, but it doesn't do it right away. So I just typed that in right now. When I did that, you see the screen blanked out, and it's put up a message which is not visible on your screen, but it says, do you want to log off? Do you want to restart the computer? Do you want to start the task manager? The task manager is a program that shows you what's running on your computer. So I just told it, yeah, I want to run the task manager. This is the task manager, and Windows has had a task manager since Windows 95. So most any of the operating versions of Windows has this. And you can look in there and see what in the task manager, which programs are running. So I got that by typing Control-Alt-Delete and telling it I wanted the task manager with my mouse. So these are the major programs I have running. I have my slideshow there. I have the DOS prompt opened up. I have the screenshot program here and a couple browsers running. Well, those are the programs that you see, the user sees. So we call those the applications, the ones that you interact with. There are other programs running too. Actually, there's a whole bunch of programs running. If you click on processes, you see a whole bunch of other programs. These are kind of programs that are running in the background doing different tasks. It also will list all the other ones. It'll list the applications too. So this is more of an exhaustive list. If you click processes, you'll see, like, for example, it lists under applications the Firefox browser I'm running right now. If you go to processes, there you see it also. But it also has a lot of programs here that you don't see running on the screen, they're running in the background. These are running, some of them are running, helping to run the operating system, doing different tasks for the operating system. You can go in here and you can end these processes, but if you end some of them, it will actually disable parts of your operating system. It's like it shuts it down. If you went in there and took your mouse and selected a bunch of these and ended them all at once, or one after the other, eventually your operating system would get to the point where it would cripple it and you wouldn't even be able to run anymore. So a lot of these are that you wouldn't necessarily want to shut down. But sometimes this can be a good troubleshooting thing here. Certainly, a lot of times we might want to shut down a particular application that's running because maybe it's not behaving right or it's stuck or something. And if you just can't get it unstuck by using the usual method of clicking on the exit or menu or whatever, you can go in here by hitting Control-Alt-Delete and you can turn off different applications or even processes that are running in the background, and maybe possibly get things working again that way. So that's what the Control-Delete does nowadays. Well, so those are all part of the Windows operating system, and one of the things that we're pretty much used to nowadays is the graphical user interface that you see when you start up the operating system. The graphical user interface is what we think of when we think of an operating system. This is what we interact with. But different versions of Windows had different graphical user interfaces. So the first Windows that was really popular, there was a Windows 1 and a Windows 2 and a Windows 3. The Windows 3 was the first one that got to be quite popular. Windows 3 did have a reasonably good graphical user interface. You would be fairly familiar with it if you ran it. You could use your mouse and click on things and move folders around and run programs and so on. It was running on DOS, so it really could only run one program at a time, but it looked like you could switch between them. You could run one and then stop and start another one. So it was quite convenient. You could switch between different programs, but it really didn't do multitasking very well. And Windows 95 was the next operating system version that came out, and it was a 32-bit, whereas Windows 1, 2, and 3 were 16-bit operating systems, meaning that they could execute instructions or data 2 bytes at a time or 16 bits at a time. Windows 95 could do 4 bits or 32-bit at a time. And it introduced new things, like it had a more elaborate graphical user interface, and it had a thing called plug and play. Plug and play was where you could connect things to your computer, and it would start to recognize them automatically and ask you if you wanted to install a driver or something like that. And so it was a big step. Up till that point, it didn't recognize anything. You had to tell it explicitly what you were adding to it. If you added new memory or you added a new hard drive or something like that, or a new printer, the operating system might not notice it automatically. And then Windows 98 was just Windows 95 with a few things added to it, but it basically didn't have a whole lot of changes. It did have better support for it introduced the internet. It had the web browser in it, Internet Explorer, and that happened in 1998. And it also had better support for multimedia, meaning video and sound. And it used the FAT32 file system, so it could have larger hard drives. So what do these look like? Windows 3 looked like that. It was fairly simple in its design, but it would be fairly familiar. It had some of the features of today's Windows. It had the windows, of course. That's where it got its name. You could put different programs in different windows, or file icons in different windows. The desktop didn't really do anything in Windows 3. It was just sort of a background. Windows 95 looked quite different from Windows 3. Looked more like what we're used to today. And it did have a desktop that actually did something. And if you ran Windows 95, you'd probably be fairly comfortable with it today. It looks a lot like what we're used to. And then Windows 98, just a little bit of this, more of the same, but a few new features, as I mentioned. Well, then there was a new generation of operating systems called the New Technology Operating Systems. They referred to it as NT. And Windows NT was supposed to be a totally different operating system. It wasn't based on DOS anymore. It was based on a whole new kernel. And it was first introduced for business stuff, business applications. And they used it a lot for servers. In those days, that was the beginning of the internet, and networks were becoming popular. So that was what Windows NT was used for. It wouldn't run games and things. It wasn't a very good entertainment operating system, so it wasn't very good for the home. At that same time, they introduced this was around the year 2000, they introduced Windows ME, so they called it Windows Millennium Edition. And it was actually Windows 98 dressed up and made a little fancier. So here's a picture of Windows NT. Windows NT looked a lot like, kind of like Windows 3, but it was a much different operating system, much more reliable than Windows 3, and it was a fairly good one for servers and things. And Windows NT 4 had a little bit more of a Windows 95, Windows 98 look to it. But again, it was used mostly for business and servers and things. Wouldn't play games very well and things of that sort. Windows ME was more of the home computer version of Windows, and it would run games and things well. Well, fairly well anyway. But that was around the year 2000. But then they got the idea that let's use that new Windows NT kernel and get rid of the DOS, because the DOS had a lot of issues, problems. Well, there were a lot of limitations to it, let's put it that way. And they wanted to upgrade it and have more capability. And they wanted to introduce a better file system, so they called that NTFS. And that's the file system we use today. And that came out in Windows 2000 and Windows XP. The Windows 2000 is actually the successor to Windows NT, and it was more for the business world. And then there was the Windows XP, which was more for home computer use. But actually, businesses used Windows XP a lot too, because they had a professional version, they called it. So it really wasn't that much different than Windows 2000, except it would support games and things better than Windows 2000. You could run games on Windows 2000 too, but not as easily as Windows XP. And that kind of went along until they decided, let's not have these two different versions anymore. Let's put all of the operating system together and call it one thing. And then that became, they first called it Windows Vista. And what it did was it had the features of Windows 2000 and XP combined together. And they also kind of redid the kernel and modularized it so that it was easier to maintain. They called it microkernel. They broke it up into pieces and made it so that it was they could change parts of it without having to change the whole thing, calling modularity. And so that was incorporated into Windows Vista, and then Windows 7, and then Windows 8, which was Windows Vista. Well, they're all very, very similar, but and then Windows 10. They use this NT kernel, so they use NTFS. So here's Windows 2000. Looks a lot like Windows 98 or Windows. And then Windows XP was a little bit more colorful. Windows XP kind of was one of the first ones that had a really pretty look to it. You know, the graphical user interface was quite colorful and somewhat three-dimensional. Had a little bit of the buttons and things, had a little bit more character to them. And then Windows Vista was much more elaborate even than that, more three-dimensional look to it. Windows Vista had a lot of problems, so they replaced it fairly quickly with Windows 7, which was Windows Vista fixed up. so then they brought out this new operating system. Of course, they had a lot of bugs. So Windows 7 came out. Windows 7 had several revisions too, and it's still very popular today. Lots of computers have, including the ones in this room, have Windows 7 on them. And then they had Windows 8, which added a interface for touch screens. So you could touch the screen with your finger and do things. And unfortunately, they took out the start button, and a lot of people didn't like that. And so they had to come out with a new version of Windows 8. They called it 8.1, and they put the start button back. But otherwise, it was still much like Windows 7. You know, ran the same programs and everything. And then now we've got Windows 10, which is, you know, combining those two. It's kind of combining Windows 7 and Windows 8 together to give the best features of both. Because a lot of people said, I really still like Windows 7 better than Windows 8. And so when they came out with Windows 10, they listened to that and they combined those two things. And so now you've got your start button that's everybody's familiar with. Plus you have the tiles that you can move around on the screen with your fingers. And again, that's what we have now. Windows 10 is supposed to be the latest, greatest version of this family of Windows. Well, that's kind of a tour of the operating system overview. What we use every day, what we interact with when we are working with the computer. Now, there are other operating systems too, not just Windows. Right? We have the Windows world, but then there's for example, Linux. Linux is a operating system that is completely a different breed from Windows. Has not a whole lot to do with Windows, other than the way that it works looks a lot like Windows. It is actually derived from an operating system that's been around since the 1970s called Unix. Unix was developed for large computers, which many people would use simultaneously. They called them timeshare computers. Some of them were what we refer to as a mini computer. They were computers that were the size of a desk, or maybe not much bigger than a desktop computer. But they were designed for multitasking. They were more expensive than a personal computer. So they were mostly used in business world, or things where people had the money to buy them, because they cost as much as a car or more, or even a house. Maybe tens of thousands to hundreds of thousands of dollars. And that's the kind of computer that Unix was developed for originally. So it was a multitasking operating system, and it was also an operating system that was developed for networks too initially. They started developing networks at about that same time in the 1970s, the idea of connecting computers together. So it had that built in. And the internet, which was just beginning to be developed experimentally in those days, networks and the internet, which were, what is the internet? The internet is a bunch of networks connected together. So Unix is very intimately connected to the networking world and the internet. A lot of the things that make the networks work that we use and the internet come from Unix. And so a lot of the features of the internet that we use today, we don't even think about, actually came from this operating system. But the PC didn't run Unix. The personal computer didn't run Unix, the IBM PC. But there was a guy from an individual named Linus Torvalds. He decided, I'm going to take Unix and put it on the PC. And so that's what he did. And he took that.
Is that what PuTTY is?
PuTTY?
Yeah.
PuTTY is a program that runs in Linux.
I mean, we run PuTTY on.
Yeah, you can run it in Windows too. Anyway, he's a pretty famous guy, and I'll show you the picture here anyway. And then he developed this operating system, which was he started developing it in the early 90s. Oh, here's Linus Torvalds. So his name is what became Linux, because his name's Linus, Linus, and Unix. So he combined the word Unix and Linus, and it became Linux. Linus is Unix. Here's a website that lists different versions of Linux. Linux is a very configurable operating system. It doesn't always look the same. Like, Windows, pretty much whatever version of Windows you're running, let's say you're running, Windows 10, then it's going to look a certain way. Of course, you can change the background, and you can change some of the ways maybe the buttons look and so forth, but it's pretty much going to look the same always. You can pretty recognize it so that you can recognize and use it, right? It makes some sense to keep it similar. On the other hand, in Linux, in the Linux world, you can customize it very much so that it operates differently. What they have is a kernel called the Linux kernel that runs in the center of it, just like Windows has a kernel. And everybody uses the same kernel, but then you can put different. It's like a car. You could have the same chassis, the same wheels and same engine maybe, but put different body on it to give it a different look. You can make a two-door car, a four-door car, a pickup truck, whatever. You can configure it. So that's what these different. This website here is called DistroWatch. It looks at different distributions or versions of Linux, and you can click on one of these and look at it. It'll tell you about it. There's one called Linux Mint, or here's a really popular one, Ubuntu. In fact, these computers have Ubuntu on it. So it's like Windows. Works a lot like Windows, but it runs different programs. It's a different world. So you run that on your computer. You can run on a PC, but it's not the same programs. You have to run programs written for Linux to do that. Just like you would Windows, you have to have programs running for Windows. If you have a Windows program, it probably won't work in Linux directly. It would have to be. Now, there are ways to run programs on different computers or different operating systems. I'll show you a nice thing that if you want to play with different operating systems, something that is a very nice thing to have is called VirtualBox. This is a free program that you can download, and you can get it for Windows. You can get it for Linux or Apple operating system and run it, and lets you run other operating systems. So let's say you've got an Apple computer and you want to run a program written for Windows. Well, you can load a copy of the Windows into this virtual box. So what is a virtual box? It's a emulation of a computer. It's like it simulates a computer. It's like running another computer inside your computer. So like here I have Windows XP. So if I click on that, see it loads up Windows XP, and there's Windows XP running in the in that window there. I can go full screen, make it look just like Windows XP, and I can run programs in it just like Windows XP can. Or I could load, say, a version of Linux in there and run it, or other operating systems. Maybe there's other operating systems out there too. But I could run any version of Windows, any version of Linux, whatever, on one of these virtual machines and try it out, play with it. And it runs separately. It's like it's a computer inside your computer called VirtualBox. You can get it for free. It's downloaded from Oracle. Oracle's a company that's big in databases and networks and things like that. In the Bay Area here, they manage the VirtualBox. So just type in VirtualBox, and you can get it, download it for Windows and play with it. And then you could take, when you load Windows into it, though, you have to have a copy of Windows, or you have to have a copy of the whatever operating system you want to install. So you would actually run it, and then you would take a copy of your operating system and run it, and you would install it inside the VirtualBox. Just like it was almost like you're installing it on your computer, but you're installing it in a virtual computer. So that's a neat thing to have for trying out and learning about different operating systems and different features. Well, I just covered on some of the things that we are learning about in operating systems. And like I said, we'll continue to go into more detail on a lot of these things in our test out lessons for this week here. Whoops, I guess clicked on the wrong box. There we go. We have section 1.4, operating system basics. And an overview of operating system, there's some videos to watch there. And then about the Windows interface, the graphical user interface. And there's a quiz about that too. So, but this is like an introduction, just like what I was describing to you. And then we'll go into more detail about a lot of the features of Windows, because there are so many as we go along. We'll learn more about that. These are things that are covered in the A+ certification, the CompTIA A+. Now, by the way, that concludes section 1. The next section is section 2 is PC Technician. So we're going to go through these in order. So you can go ahead, if you finished up chapter 1, go on into chapter 2. And again, just go through these in order. As these are completed, there'll be a little green check mark there that says you've completed each section. And you want to do them in order. So just keep going through them. And then as we go along on our class website, I put a place for you to enter the points for each of those on our class website. So like this one for section 1.4 here, you just click on that and you can, oops, I'm logged out, I guess. And then it says there's a quiz there, but it's not really a quiz. It's just a place that says you've completed this section, and you click true and click next and submit. So it's not really a quiz. It's just a place to do that. And the reason why I can let you do that, I mean, I guess it would be the honor system, of course, but it also does, test out does give a record of your progress. So just like you see the green check marks here, the teacher can also see the green check marks. So I know that, verified that you did complete that. So there is a verification. progress that is available through TestOut. But you might ask, well, why, if the TestOut keeps a record of it, why do you have me putting it on our class website? Well, the reason for that is we do other things in our class too, and I'm combining all of those together into the gradebook on the class website, which is a simple gradebook, but at least it puts everything together, whereas the TestOut doesn't do anything but the TestOut stuff. So that's my way of putting everything together in one place. So when you click here for grades, then it'll list everything we've done so far. And as we keep going along, I'll keep adding things. Now, just because these things are on here doesn't, and some of the things that are on TestOut aren't listed there yet, doesn't mean you can't go on. If you want to, of course you can go on and test out and make, if you want to go charging ahead. I'm just pasting the class here, so, and I try to, add to the content of that particular thing. By the way, I didn't add my points here for my free 10 points. I'll do that real quick. Now, if I go back to the home page here and look at the gradebook, which is up here on the corner, you see now I have the 10 points in there. And if I look here and I see something's missing, I can just click on that and you can go in and put that in there. Let's see. So that would appear in there then. So that's that. So it's pretty simple. Does that make sense to everybody? Everybody able to, I know a couple didn't get that account created on there so you could have that gradebook. So you do have to have that account on our class website, otherwise it won't have it. There's no entry for the gradebook, so you won't have a gradebook. So okay, so next week it'll be about safety and professionalism. That's chapter 2. So I'll put up another topic here on a class website, and we continue going through the class. And we are working on a project where we are looking at the different parts of a computer, and I ask you to take pictures of it, either with a camera or a screenshot or something of 20 different parts of a computer. And I have a pretty good list of them here, but not exhaustive list. There might be parts that you pick out that aren't on that list. And then I'd like you to show a picture of it in your slideshow and identify it and tell us what it does. What is its function? Not a lot of detail about it necessarily, but what does it do in the computer's function? And that might require a little research on your part to find out more about each of those different parts. But just a brief interval for each one of these. No more than like 15 seconds or so, because if you do 20 things, that gives you about 5 minutes, 4 per minute. Right? You're not going to go into great detail on any of them. But that's a survey, giving me a survey or a tour of your computer. That's what the idea is there. All right, well, we're out of time for this session, and I'm going to take another little break here, maybe have a snack or something, and I'll be around this evening to help you with your project or whatever you would like to do with that time that we have here available to us. I'll hang around here to help you with things. So whether you're doing the project with a computer in the locker or you're doing a project with a computer that you choose for home, you maybe have a machine, you can do that as well for this project. You don't have to use one of the computers here. So, and also in the instructions here, I wrote that you could, if you wanted to, if you have no other option, and I'm mainly talking to people that are online, if they're not in class, regular class, that you could use the simulated computer as in LabSim as your computer. It's a Dell. It looks like one of these computers, right, that's in our locker. It looks very similar. So that would be another option. You could find some of those. You can magnify and screen capture parts in there. Well, thank you for coming as usual, and thank you for participating, whether you're in person or you have come in person today. So we'll see you again soon. If you have any questions or